Okay, so we've made the increasing, decreasing chart. Now we can do our local maxes and mins. So here, I go from increasing to decreasing. And so, got a maximum. Increasing to decreasing, it must be a maximum. Until we go back and remember, it's undefined at x equal 1. And so at x equal 1, there is no local max. Original function is undefined for x equal 1. Now, if you forget that, what's going to happen is you will then try to find your y-coordinate. You will plug in to get your y-coordinate, but when you go to plug in your y-coordinate, it's not going to work. And so you will get a little reminder, oh yeah, it's undefined at 1, so I don't have a max or min. So even if you forget forget kind of from the get-go, you're just so excited, gotta be a max, gonna have a maximum there. When you go to find the y-coordinate and you try to plug in 1, you're not going to get a y-coordinate, and that should remind you, oh yeah, undefined, so I don't have a local max or min. But I certainly did have a change in the increasing, decreasing, because that is going to be an asymptote. At x equal 9, with y equal f of 9, always the original function. And I'll put my original function in the calculator here, and hopefully my calculator will deal with it. It's asked for new batteries for a really long time, and I just keep not remembering to do that. So you can just wait here while I type all this in. So if I plug in 9 into there, plugging 9 into there gives me roughly negative 10.3125. And so 9, negative 10.3125 is a local minimum, because I go from decreasing to increasing, so it has to be a minimum. And so there's my increasing, decreasing stuff. Now I can move on to my concavity stuff. Concavity stuff is the second derivative. And we were given the second derivative as 130 minus 10x divided by x minus 4, quantity squared. Possible inflection points. Second derivative equal to 0. Give me 130 minus 10x over x minus 1 to the 4th equals 0. Clear that fraction. And without too much fuss, I get 130 minus 10x, which will give me x equal 13. Then the does not exist case. Again, I look at that denominator, and that x equal 1 creeps up again. Any place where that denominator, where the original function is undefined, is going to keep creeping up over and over and over again. Now I make my concavity chart. So I had possible inflection points of 1 and 13. So negative infinity to 1, 1 to 13, 13 to infinity. Test value. And again, notice, I don't put 0 in there because I didn't calculate 0. I've never quite understood why so many students automatically put 0 in there. Now I'm going to use 0 as a test value, but it doesn't go in that first line. So I'm going to use 0 as a test value, 2 and 14. And then I plug into the second derivative, which is up there. And so just try to analyze it out. If I plug 0 into the numerator, that's going to be 130 minus 0. The numerator is going to be positive. If I plug 0 into the denominator, notice I'm raising it to the 4th power. I'm raising it to an even power. Well, any real number raised to an even power is positive. So my denominator is always going to be positive. So I got a positive over a positive for positive. Plug in 2. Well, that's going to be 130 minus 20 on the top. That's positive. The denominator is always positive. So I have a positive over positive for positive. And lastly, plug in 14. If I plug 14 into the numerator, that's going to be 130 minus 140. That's going to be negative. The denominator is always positive. So a negative over a positive is negative, which then tells me that f of x is concave. Up, up, and down. Positive second derivative means I'm concave up. Negative second derivative means I'm concave down. And because I see that change, at x equal 13, y equal f of 13, original function, and you just ask your calculator what that is. If I plug 13 in there, I get roughly negative 10.2778. And so 13, negative 10.2778 is an inflection point. And there's all my concavity work. So now, because this was a fraction, I'm going to go on to my asymptote work. Okay, let's recall that the original function way back when was f of x equal negative 10x squared plus 15x plus 15 all over x minus 1 quantity squared. Wrote down the original function so we could see it again, but also gives me opportunity to say asymptotes are about the original function. We aren't going to do any derivative work here. It's about the original function. So vertical, we did a little two-step process for vertical asymptotes as far as finding them. One, where it was undefined. So very technically, x minus 1 quantity squared, where that's 0. And that gives me x equal 1. Then 2 was verify that the numerator is non-zero. And so if x equals 1, my numerator, which was negative 10x squared plus 15x plus 15, equals negative 10 times 1 squared plus 15 times 1 plus 15, which happens to be 20. But all I care about is it's non-zero. That's all I care about. I don't care what the actual number is. And so that tells me we have a vertical asymptote at x equal 1. Now, to help us in graphing, and you can actually live without this step, but it'll help us, I'm going to find a point on either side. On either side, but close to x equal 1. So I'm just going to make an old-fashioned t-chart. And I'm going to pick 0.9. And actually, in a mathematician's world, that's really far away, but it'll work for us. And 1.1 on either side, and then plug into the original function. So if I plug in 0.9 into the original function, I get 2040. Now, not that we're going to count all the way up to 2040, but what this tells me is on the left of x equal 1, go up. 0.9 is on the left of x equal 1, 2040, we're going to go up. And I do the same thing with 1.1, and I get 1940 there. And so we get the same thing here, but on the right of x equal 1, go up. Now, like I said, you can live without that information, but every piece of information you get helps you draw the picture. Then my last calculation here, my horizontal asymptote, I look at the limit as x goes to infinity of the original function, which was negative 10x squared plus 15x plus 15 over x minus 1 quantity squared. And I'm just going to FOIL out the denominator. So I have x squared minus 2x plus 1. Then my degrees are equal here. So that's going to be negative 10. The degree of the numerator equals the degree of the denominator. And so we have a horizontal asymptote at y equals negative 10. And there are all my calculations. And now I just have to graph it. But again, we think before we graph. So we're just going to do this on another piece of paper. The things I have found. We have found that there's a local min at 9, negative 10.312. There's an inflection point at 13, negative 10.2778. Vertical asymptote was x equal 1. Horizontal asymptote, y equals 10. So there's the important stuff. Important x values. Turned out to be x equal 1, 9, and 13. Important y values turned out to be, and this is supposed to be y equal negative 10 here. That was a typo. Important y values, y equal negative 10, negative 10.2778, negative 10.312. And so what we're going to do on the next video is we're going to think very carefully on how we want to label our x and y axes to represent this information. And so clearly the standard window of going negative 10 to 10 is not going to work because these numbers are smaller than negative 10. So we think very carefully before we draw, and that's what we'll do on the next video.